Buongiorno e benvenuti a tutti. I hope that sounded quite right. Is that okay? Is that somewhat Italian? All right, let's do this. This talk is called Elasticsearch in Action, and the reason I call it Elasticsearch in Action is because I've seen way too many presentations about Elasticsearch that spend 40 minutes explaining what Elasticsearch is. I'm going to explain what Elasticsearch is in a single slide, and I promise you that. And right after that, we'll dive right in, and we're going to go with an action-packed presentation. I promise you one single slide. You ready? Let's do it. Elasticsearch is and I'm going to try to sound as boring as I can to give you this one. Elasticsearch is a full-text search engine. It is also a NoSQL database. It's also an analytics engine. It's written in Java. Sorry about that. It's based on Lucene technology, just like Solr. It has inverted indexes. It is very easy to scale, hence the term elastic. It has a RESTful interface, and that's quite interesting. You interact with it over REST. It's somewhat schema-less, somewhat. It's good for semi-real-time stuff. And there's this thing called the ELK Stack, and I'm going to leave that for the end. So that was that. Are you still with me? That was the theory for today. Let's dive right into the action, but before we dive into action, I need to formally introduce myself. Hi. Hello, everyone. My name is Thijs. Yes, that's the way you pronounce this name. I am Belgian, and I am Thijs Feryn on Twitter, if you ever heard of Twitter. You can follow me on that one. I'd love to interact with you, talk with you afterwards, answer questions if you want to, because I'm not sure if we'll have time enough for Q&A. Professionally, I'm a tech evangelist at a Belgian web hosting company called Combel, but most people probably know me for my involvement in the PHP community, and more specifically as an organizer of the PHP Benelux events. That was the intro. Let's dive right in. What's the first thing you need to do when you want to work with Elasticsearch? Download Elasticsearch. This is the link where you get the stuff. It's quite easy. It has it for all platforms. Even if you want to do some testing on your computer, I have a Mac. I had some Mac-compatible software there. It's a folder. You extract it. There's a binary folder. You start a binary. Done. How do you address it? I mentioned to you that it's RESTful. So the only thing you need to do is point a browser or a other client like curl, I love using curl, point it to localhost 9200, and this is what you get. And when you see, for search, then you know you've set it up right, and you can dive right in. There is a bit of specific lingo, some terms you need to get familiarized with. I'm going to compare it with RDBMS systems we are well aware of. What we call a database in RDBMS world, we call an index in Elasticsearch, which might sound confusing because you have indexes in RDBMS terminology as well. But because Elasticsearch indexes everything, you don't have to put indexes, they just call it an index. What we call a table in RDBMS land, let's say MySQL or Oracle or what have you, it's called a type. And what we call a row is called a document. We agree? Okay, let's do this. Creating a database, I'm going to use the term database now. Creating a database, or an index as we call it in Elasticsearch terminology, is just doing a post to the name you want. We call this blog. I'm going to give a fair number of examples of the blog. So what I did in preparation for this presentation, I wrote a script that reads the atom feeds of our company blog and indexed all of that in Elasticsearch. So a lot of the stuff you'll see is just blog posts. But I did not include the blog post itself, just the title and some meta information. So to create this, you only have to do post/blog. Any idea what kind of HTTP status code this will give, just as a teaser? Come on. We create a database. 201, yes, brilliant audience, thank you. And if you want to feed it a document, you just send it some random JSON, post it to the index, give it a type, give it an ID, and you're good to go. This is just some random stuff I fed from our corporate blog. And I will give it 201, it will give you some meta information. And that is as easy as it gets. If you can work with an HTTP client, you can work with this. Retrieving is also easy. You just do a get, and you get the index, the type name, the index number. This is your document. If you did not specify, like, let's go back. If you did not specify the identifier, it will choose it for you. It will be a hash, a random hash. And then you can use that hash to retrieve it. I told you it was schemaless. I actually lied. It's not really schemaless. It takes the burden off you of choosing a schema. It will guess the schema for you. And right here, it guessed it wrong. I fed it data. Let's go back to the data. This is the date, Tuesday, 15th of December, 2015, and the time and the time zone. It turned that into a string. But that's not a string, it's a date type. And that nice little GUID, this one, 6160, it turned that into a string as well. So that's not really good. So it guesses, but it can guess wrong. So that's where explicit mapping comes into play. You want to define a schema. A lot of people say, oh yeah, we have highly unstructured data. We never know what data is going to be fed in. Be realistic. In a lot of cases, you will have a pretty good idea of all the data that will be fed into your system. So let's do this. Let's create an actual schema for the data we created. The only difference is that we create a type date and we mention the format. Because we have a very specific format, we have to specify this, otherwise Elasticsearch won't be able to deal with this. And the GUID is explicitly an integer. You feed that again via post command, and it will create that. The next time you insert a document in it, it will respect that, and that one will be done. Let's pick it up a notch. Let's make it a bit more interesting. And I hope you can read this in the back. They specifically asked me to have a minimum of 48 as the font size, but I didn't manage for this. So what we're doing here, and I'm going to zoom in a little bit further, is we're defining all our properties, but we're adding some weird keywords, as you can see. Not analyzed, analyzer English, analyzer Dutch. I'm adding fields to properties. What's that about? Let's zoom in. So let's give you the overview, because this is where it gets a lot of fun. What we do is we specify that our title exists as a property, so you can send it the title of a blog post. But if you want, that data could also be structured in another way as a sort of copy. And I want it to be analyzed in English, in Dutch, and I also want the raw formatting. Raw formatting means that it is not analyzed. So what that means is we're coming into a situation of choosing between analyzed data and non-analyzed data. Basically, full text search on human language or exact values like you do in a database. By default, strings are analyzed. So it takes a string, chops it up into bits and pieces, and stores it in a very specific way. That's just in the index. The original source document is never touched. It's left intact. So you still have your source document. So what it does, the analyzer, is it first uses so-called character filters. It takes characters and throws characters out it doesn't feel that is relevant for the indexation process. Next up, it tokenizes the rest of the text, and then it uses token filters to remove certain aspects of it. By default, it's the standard one, and you have a bunch of those. This is just a small list. There's plenty more, and you can influence the way your text is dealt with by doing this. It uses a standard tokenizer, lowercase tokenize, token filter, and so on, and so on, and so on. So let's do this. This is a piece of text. This is a piece of information that might be useful to you. So I figured this, I wasn't really creative at that time. I just took a random catchphrase from English. Hey man, how are you doing? If you would analyze this, and there's a way of doing this in Elasticsearch as well. In the end, I'll have a link with the examples. You can fiddle around with the examples yourself, and you can use the analyzer engine to just feed random data to it without saving it in the database, but just seeing how the analyzer responds. If we use the standard analyzer, it will chop it into, hey man, how are you doing? Notice that it removed the question mark, and notice that it removed the comma, because those aren't really relevant to human language. If we would use not the standard one, but a white space analyzer, it will keep it intact. There's a comma here, there's a question mark here. If we would use the English one, it will reduce certain words to their base form. Hey all of a sudden has an I instead of a Y. And doing, the verb doing, is reduced to do. And is a stop word, we removed it. So if we go back, all the way back to our analysis process, maybe zooming in, what we do is we store the title as an analyzed string using the standard analyzer. If the data that I store in it is English, I might want to query it using the EN field because we know it's analyzed as English. If it's Dutch text, that's my native language, it will be stored as Dutch. And if we don't want it to be analyzed, but if we want the full set, we use the raw. And that way, if you manage that, life will be easier for you and you have lots more capabilities to leverage. So let's get back to the business. This is an example of using, this is a query. This is what the query syntax looks like. So you posted a piece of JSON. What I ask is, just return the title field. It's like selecting title from blog.post where title equals working. That would be the corresponding SQL query. So what I ask the system is, give me the title of each blog post where the word working occurs. So what it does is, if I use this one, it will just return a single blog post. Hosted SharePoint 2010, working efficiently as a team. So the working, it's an OR match, so it looks for a term. If it's there, it will return it. If we would do the same thing on the .en field, boom, a lot more results. It will find work because it will know working comes from the word work, so documents that match the term work will also be returned there. And it gives a relevance score to it as well. So this is easy to dig deeper, to return data that might be relevant to the user. Let's talk about search in detail. Let's dive a little deeper, right? And look. Elasticsearch is quite simple, and it's a small, compact tool. It's not the size that matters; it's what you do with it. That's what they say, right? So let's go into this. If we would just do search without passing on any parameters, we add the pretty because it prettifies your JSON. It indents it, adds new lines. If you don't do that, it will be one long piece of JSON. It will return every single document in the block index and within the post type, so all of it. But it will page it, so it will output a given number of results, and then you can use a cursor to loop through it. So this is a lazy way of getting all the data from all our blog posts. If you would turn on that search light, as I call it, if you would make it a bit more complicated and use the full-on search, this one could be turned into this piece. We query it, and we match all documents. And we're going to stop using search light in just a minute. I'll show you a single example. What you can do is say, I want all the documents where my name, Thijs, is returned in the title field. I can turn this into a match query, which you already saw in the previous example, and this will return our document. So there's a search light using the query string, which I would not advise because it's not that powerful. But if you use posts here and pass it along some payloads, you'll have a much more elaborate way to search and to retrieve data. You can also count. So if you don't do search but underscore count, it will count the results. So what I'm interested in is all the blog posts where the title matches proxy protocol support in Varnish, and that would return 162 posts. Why? Because it's an OR match. It looks for proxy, it looks for protocol, it looks for support, it looks for in, and it looks for Varnish. So every time a document matches either of those, documents will be returned. If I use the raw field, if you remember the mapping correctly, it doesn't analyze, it's the full text, it matches one single document being that very blog post. So lots of opportunities, lots of possibilities. But my goal is to show you that this exists, because before I dug in deeper in Elasticsearch, I created a system that indexed email logs. And the email logs, the identifier contained dashes. And whenever I looked for it, I couldn't find it because the dashes weren't indexed. And then I learned about mapping, non-analyzed data, analyzed data. And that got me into this. So let's go on to the next step. I showed you how to query the database. I mentioned a bit about filters. Let's answer or show you the difference between a filter and a query. Filters are faster. Filters are like exact matches on values. It's like what you do in SQL, select asterisk from table where key equals value. That's what a filter does. And it only responds to the question, does it match yes or no? Queries are better for full text search data, and they do a relevance scoring. So they guess how relevant this is to you. This is ideal for human language if it's not human language, but just exact values. So in the case, and let me try to go back to the document. This is an exact value. It will be either ENUS or NLNL. This is human language. This could vary. This is an exact value, but it's a date, so it won't be analyzed in any way. It only applies to strings. This is an exact value. These are exact values. This is an integer. So for the majority of our fields, we'll be using filters. But only for the title field, in this case, we'll be using queries. And there's a lot of queries. Like I've only shown you a bit and a piece. Go to the Elasticsearch website, and you will see all the kinds of queries they have. And for filters, they also have a bunch. Like you can do an amazing amount of things with that. Let me show you some filter examples here. Let's dive in deeper. I showed you how you can do a get on a single document ID, and that would return all the document IDs. Well, in this case, if you want a multi-match, if we want to have multiple documents, we can use the IDS, the IDs filter, pass it along a set of numbers, and it will retrieve those very documents. It's a simple one, but yet a convenient one. Next up, we're going to use the Boolean query, and that's a way of mixing multiple filters or multiple queries or combinations of filters and queries. By using bool, you have three terms. You have a must not, and should. In logical operators, must is an and, must not is not, and should is or. So let's try figuring out what happens here. We're doing a filtered query, so we're going for exact value matches. We're not going to interpret human language. It's going to be on non-analyzed fields. And we say that every document should be written in English, and the date range should be as of the beginning of this year up until now. The category should definitely not be Joomla, because we don't care about Joomla blog posts, right? We don't care about that stuff. And it should either contain a category being hosting or evangelist, and or not. Combine multiple ways, design more complicated filters. Another one is if we use an exact value match, but with a wildcard, we could say, let's prefix it on the raw field and look for everything that starts with Combel, which is the name of my company. So every document that has Combel or any other business would be returned in that way. This is where it gets really fun. If you have geospatial data, you can throw it in, and you can map this as being a geopoint. It only works on geopoint stuff. And you can say, this is the very location of my city in the west of Belgium. And I said, I want to know all the little villages that are within 5 kilometers. Now that data being fed into it, I got that from the MaxMind geo database, which is freely available. I filtered it down because if you want to index every city in the world, it will take you some time. Even all the cities in Belgium was more than 100 megabytes of plain text data, so that was a lot. So I indexed all the cities from my region, from my province, and I said I want to know everything in a 5 kilometer range from my place, and it just did that. And it even learned me that there are small villages that I've never heard of that are close to where I live. So interesting. You can take it to the next level if you want to, and you can filter on a geo-bounding box. So what you do is you give it a bottom left and an upper right, and you draw a box around it, and it will return every document that has a field within there. So if you're working with let's say, mobile devices and you have geodata, this is very useful to retrieve documents that match this. So use it if you can. I like this. Next up, relevance. Let's dig into relevance for a quick second. Let's have a look at this query. So what I'm doing here is a Boolean query, and I'm interested in every blog post where the title contains either varnish or my name, Thijs. We return those, and the language must be US. So what we're doing here is combining a query and a filter. So we're using full text and examining some exact matches. This will be faster than using queries for everything, especially if your data set grows. If your data set grows, this will save you time because these filters will be cached. So that's a nice way of doing things. So you can see, if we talk about relevance, that this document contains both Thijs and varnish, so its relevance score will be higher than the second document that only contains varnish. So we boosted the relevance there, so that's a good one. If you use regular queries, and this is what we're using here in the beginning, the sorting will be done on relevance. If you use filters, you can define the sorting yourself. Because let's show you here, we're going to filter on the category PHP Benelux. It will have a constant score of 1. There'll be no difference in score. And then it makes sense to add your own ordering. You can order on a field where you want it to be ordered. And in this way, we treat Elasticsearch more like a NoSQL database rather than a full-text search engine. I use it more as a database. This is my go-to database. A lot of people say, well, there's Mongo out there and CouchDB and what have you. I like this because I tend to know it a bit, and it's cheaper for me than running MongoDB, and I'll show you in the end why that is. I'm not bashing MongoDB. I'd like to learn more about MongoDB, but this is easy for me because it combines full-text search, NoSQL features, and I'll show you about the analytics engine as well in just a minute. This is also a cool one. So let's look at it a bit deeper. It has a must and a should. It's an or. What it does is it says, look for all the documents that contain my name, and it will look for either Thijs or Feryn. So documents that contain just my last name will be returned as well. And if the category contains varnish, the relevance will be increased. Now, mind you, we've done these shoulds in combination with filters. When you use filters, the or is not optional. It needs to be there. In queries, it will only be used to boost the relevance. So if you use a should, and it doesn't match, documents would still be returned, but the documents that contain varnish will be boosted. Will be a higher score, will be higher in the result set. And you can combine it in the other way around. We do a filtered query where we look for all documents that were written by my colleague Romy, but we want to sort it based on relevance. So if it contains Magento, boost it. So you can see the intricate differences between queries and filters. Use them wisely, I'd say. Let's continue on. This is query time boosting in your logic. So what you can do is define a relative score, boosting score. And in this case, we want Magento documents have a 3:2 ratio in relevance. So for every document, Magento is 3:2, so 1.5 times more relevant than WordPress documents. So this is a good way of even controlling it better. Okay, next up, multi-index and multi-type. So throughout this presentation, I've only talked about retrieving data explicitly from the blog index and on the type index. ElasticSearch can do way more, and this is an overview of capabilities it has, and that's something that SQL doesn't have. You cannot select all documents from all tables from all databases at once, and if you do that, it will be highly inefficient, I guess. In ElasticSearch, you could say search, and it will look for all the data in every database, in every table, so in every index, in every type. And it will cursor it by 5 or by 10, and you can define the size of your cursor. You can also say, I want all information out of the products index, regardless of the type, regardless of the table. And you can continue on. This is an exact one for every product in the products database. Next up, you can define multiple indexes to search. Like, I'm interested in all the clients and all the products, return me that data. And then you can have specific payloads by doing a post to define what you want to be returned. It goes even further. You can use wildcards. You can say every index that contains the word pro and whatever that fits after that could be returned, and so on and so on. You see it, right? You can combine multiple wildcards. You can do the same thing for types, and you can use the all keywords to say I want everything from all indexes, but every time from the product or the product and invoice and so on. So multi all the things is exactly what I'm trying to mention here. It's a powerful way of returning data. Next part of the presentation, aggregations. And this is why, so people tend to like Elasticsearch in the beginning, and when they learn about aggregations, they fall in love with the product. It's basically group by on steroids. It's the third part of the theory. First one, it's a search engine. Second of all, it's NoSQL database. Aggregations make sure that this is a analytics engine. It's a cheap one, it's an easy one, and a lot of people use it for simple BI and simple data analytics. So simple data science. It's not as elaborate as a lot of other technologies, but it does the basic job. Let's go back to SQL for a minute and see what happens there. We have aggregations as well. We call them group by. We say select the author and the amount of documents based on the GUID fields from the blog post and group them by author. We have a bucket. This is what we're grouping by. We have different buckets, and every bucket will have a metric. Well, in Elasticsearch, we have the very same thing. What I'm doing here, again, is using the count, not to return the actual documents that match, but just to return the group by information. If you don't do this, you get both the information you're querying for and, on top of that, aggregation, so you can combine both. That's also something that SQL does not do for you. So we create an aggregation. It's called, this is the name, the given name I'm giving my aggregation. It's called popular blog posts. And I'm using a terms filter on the field author. And the only thing it will do is for every author, it will count the number of blog posts in there. And this is what gets returned. My colleague Romy, she's works in the marketing department, has 415 blog posts. We also have our anonymous Combel name. It has 184. And then we dive in all the way to Christophe, who is our marketing manager, who only wrote 23 blog posts. We can dig even deeper. We can do it nested. So what we're doing is the very same deal, the popular bloggers, and for every bucket, we want sub-buckets. So we want to know the difference in language. How many were written in English? How many were written in Dutch? And this is how it gets returned. Very same results in red on top, but then it dives deeper. Romy, oh, and it contains a filter as well. I forgot to, or a query as well. All the documents where varnish is matched. Romy wrote 4 blog posts about varnish. 3 were in English, 1 was in Dutch. You see where this is going? This is going deeper and deeper and deeper, and you can get some really interesting statistics and information about documents that were indexed. And there is a bunch of aggregations. As you can see, you also have geo-aggregations. You can write graphs, histograms, date histograms. It's all in there. Next up, managing Elasticsearch. That's also an interesting one because we talked about Elasticsearch more or less from a developer perspective. But hosting Elasticsearch and making sure it's readily available and accessible is a different story altogether. There are plenty of ways to manage Elasticsearch, and that's a different talk as a whole. We're not going to dive into all the specifics, but I'm going to show you a couple of bits and pieces. The reason why it's called Elastic is because it scales very well, and it has a built-in clustering model that is quite okay. There are some caveats, of course, but every technology has that one. If you have a node, it will slap or divide your data up, every index up, into shards. Shards, for those who aren't familiar with the terminology, is, let's say we have a regular SQL database, let's say MySQL. If we have copies of our database, like we use replication, every database server will have the exact same data set. So if we have load, lots of load, we're going to distribute the load by having multiple servers using replication. But the problem is, as your data set grows, every server should contain all the data. And that's a problem. And that's a thing that sharding solves. It looks at your data set and it chops it up into pieces and divides the pieces among the various servers you have. Because we only have one single server, and because in the settings of this index, or this server, there's only 3 shards. By default, there's 5. It will keep them on the very same server. It also has a concept of replicas, so we can have replicas of our data, copies of our data that will be distributed. Even if we define that there's replicas, it's not there because there's a single server, and Elasticsearch is smart enough to figure that out. As soon as we add a secondary node to the story, Elasticsearch is getting smart and it's is this working? Okay. Replicating every shard to the secondary one. There is no actual sharding happening because there's only 2. The first one contains all the primary data, the second one contains all the shards. As soon as we start adding a third node, this is when the actual sharding happens. It will dynamically, like on the fly, start moving data across to spread it equally. And the more replicas that you have, and it's like a RAID controller, the more power you have for searches, because it could distribute the searches among all the servers you have and return data faster. Now, there's a cost to having more replicas. It's a writing cost, it's an operational cost. I tend to stick with a single replica. If the data is that valuable, add more replicas. Because in a lot of cases, you don't use Elasticsearch as the source of all truth, like a lot of people do, but other people say, we're going to use our relational database as a transactional piece of database that we trust, that we know, and we're going to add Elasticsearch as a layer on top of that to index certain data to make accessibility a lot faster. We're going to flatten some queries into views. We're going to store those views in Elasticsearch. A lot of systems do that because if you do all of this, like these complicated queries and full text search in relational databases, that will slow you down quite dramatically. So as soon as we have a 3-node cluster, it will start distributing it. Configuration is really, really easy. This is just an example. The thing you need to do is you have to give it a cluster name. And all the nodes that are within the same network that have the same cluster name will automatically join. You don't have to do an elaborate strategy of grouping nodes. No, Elasticsearch will do that for you. It will find it. It will use multicast or unicast, and you can define that. Look for nodes, group them into a cluster, start sharding along. So as a sysadmin, this is kind of easy. if you have, like, the minimum amount of servers you need to have a decent cluster, the minimum, it's not the optimal, is 2. Like with 2, you have your basic one, and if that one falls over, you have another one. But the problem with clustering systems and consensus systems in general is if a vote needs to happen, let's say there's a network partition and the connectivity between them is dropped, they individually still process data. When the data the network comes back up, they need to reach this sort of consensus. There's a vote, and the tricky bit is the one that loses the vote drops all its data, which is a nightmare. So that's why I would advise, if you have a mission-critical system, have at least 3 nodes. And set this one, discovery, Zen, minimum master nodes to 2. So what will happen is you should at least have 2 master nodes, 2 master legible nodes. If a node gets disrupted from the network, it won't be able to find a secondary server. And it will say, oh, I'm in trouble, I'm alone. And it will go down gracefully. That's a good thing. You rather have a system go down than become inconsistent. You can define on a server level the number of replicas, the number of shards, and so on and so on. Shards and replicas could also be defined in your index. So per index, you can define the number of shards, number of replicas. And these are another bunch of cool things. You can define if HTTP is enabled. So if you have a big stack of servers, let's say you have 20 or 30 Elasticsearch servers, you can choose which ones are data nodes, which one are master nodes, and which one are HTTP nodes. And you can start dedicating certain nodes to just processing incoming requests. You can tune, also on an operating system level, certain nodes that only store data, and then nodes on the side that participate in the master election. But that only works if your cluster is big enough. And if your cluster is distributed among many locations, you can use, this is just a value rack, like nodes that are in the same rack, you give them the same name. But rack is just a keyword, you can add other keywords. You can use node.datacenter, you give them the same data center. And Elasticsearch will be smart enough to distribute data or not to save replicas on nodes that are too close to each other. It's going to put it a bit further out. If a data center dies, you still have data there. So Elasticsearch is that smart. In terms of manageability, there's lots of APIs there, which are all JSON, which is not always easy to read. But they have these APIs called cat. So if you do a get of /_cat, it will be like cat on Linux, the cat binary, right? It will just be key columns and rows. And if you do this, you'll see a nice funny cat at the first line, which always makes me smile. And then all the APIs that you can manage. And there's a bunch. You can manage your indexes, your nodes, your masters. Let me show you an example. If you do cat shards and do V to display the columns, you see every shard on your system, on which node it is located, which IP that node has. If it's a primary one or a replica, and you can see that we have 5 shards and 10 shards in total. 5 are primary, 5 are replicas, and you can see that I have a 3-node cluster. It's out there. Another thing you can do is check the cluster health. If one node goes down, you might lose replicas. If the status is green, that means all primary nodes are there, all replica shards are up. If it's yellow, that means primary is up. Some replicated shards might be missing. That's not a disaster, but it's a cause for alarm. If it's red, you're losing primary data. And you can use that in your monitoring system. You can refer to that, and you can even filter out the word green. So if the word green is not there, you're in trouble. So that's a good way of monitoring it. On a final note, because I think we have 5 minutes left, I promised you I'd mention something about the ELK stack. Who has heard about the ELK stack? For those who haven't, ELK stands for Elasticsearch, Logstash, and Kibana. Those were separate open source projects, but now they're coordinated by the Elasticsearch company, the company behind the open source project. What it does, Logstash, as the name mentioned, is really good at processing log information. Because Elasticsearch is a good NoSQL database, it can do full text search, and it has an analytics function, it's a great way of storing log files for visualization purposes. And in the end, you can drop Kibana on that, and Kibana will visualize the things you have. ELK has become more interesting ever since the new Beats product was released by Elasticsearch. It's also open source. But the problem with Logstash is it's a big Java application, and it might be heavy on your system just to extract logs and save them in Elasticsearch. So the new stack is these lightweight Beats services that are written in Go, can analyze files. So that's file beats. You have top beat that can analyze process information. And you also have beats that can check network traffic, so you can examine network traffic. Over its own protocol, it will send it to Logstash, and Logstash can parse it, could analyze the data, could re-index the data in a certain way, store it in Elasticsearch. Kibana will visualize this, and this is what this could look like. It's a nice looking interface. It's an easy way of creating dashboards that you can project on your big ass LCD screens in the office and see what is happening. It could be used for sales, it could be used for checking servers, it could be used for internal application data. It's just the simplest way of composing really shiny and nicely looking, manager-friendly dashboards. On a final note, this is how the presentation will end. How do you integrate Elasticsearch if you're not using it for logs, but just as a search engine, an analytics engine, a database? How do you integrate it? Well, my simple answer to this is it's REST. Deal with it. And if you're not dealing with it, or if you want a bit more layered around this, there are APIs and SDKs and nice little libraries in every other language you want. Now, we covered a lot of information today, and I encourage you to test it yourself. What I created for you is a GitHub account. You need to download two things. You need to download, these slides will be online, don't worry, so no reason to write it down. What you need is an Elasticsearch. If you use Windows or Mac or Linux, it's readily available. You just drop it there, extract it, run the binary. But you also need to install Kibana. Not for visualization, but just the framework, because we'll be using the Sense plugin. And I have all this information on the GitHub repository. And Sense is like an IDE for Elasticsearch. You can start typing queries and it will autocomplete. So if you're looking into learning the query DSL, it's really an interesting and simple way of doing it. All these examples are linked to Sense. So all these data sets are in there. So the only thing you have to do is click a link, Sense will open, press play, and all the example data sets will be in there. All the queries I showed you will be in there and more. So that's a good way of playing around. And this is what Sense looks like. So it's on localhost 5601 is your Kibana app Sense. And you can throw stuff in there and it will return it in a nice way. So that's the end of the presentation. If you want to follow other stuff I do, I have a blog, I have a YouTube channel where I do interviews and tech talks or do tech reviews. I have a podcast, I have Twitter. And you can also follow me on iTunes. Again, these slides will be available. I'll upload them and distribute them over Twitter. Thank you for being part of this. Thanks to the organizers for inviting me. I have another talk, I think this afternoon, about using, if you're running PHP and PHP is slow for you, how can you solve this by using non-PHP technology? So that's another one I'm using. Thanks for the attention. Thanks for being there. Grazie mille.